Okay. Unit 2, Skill 1. How do we determine if a relation is a function or if a relation is a one-to-one relationship? While you're copying that down, I'm going to mention that, hey, it's almost the end of the quarter right now, and you probably want to come in and do test corrections if you want to raise your grade. Remember, every single skill grade can be raised up to a 100. All you have to do is test corrections and then a retest. The WPR grade is the only part of the grade that you cannot change, even if you need to do multiple retakes. All right, it's not ideal. We don't actually love that, but you know what? I will sit here, Ms. Griffin, Ms. Davis will sit here, and we will make sure that you guys get it for multiple retakes. So here we go, functions and one-to-one functions. This is kind of a review, so I'm going to be going through it a little bit quick, which hopefully you'll enjoy. So function, any rule that assigns exactly one output, one y value for each x value. One y for each x, and that is supposed to say x there. I just caught that it doesn't look like it. Sorry. One y for each x. All right, so that is the definition of a function. To tell if something is a function, we're actually going to use the vertical line test, but we'll get to that in a little bit. So function notation. You have an output, all right, and then you have a rule, right? F of x equals something. Right, like right here is the rule. And then you have an input, and you're going to plug in for x. Now, y and f of x are interchangeable. If you didn't know that, you really do need to know that. So what I can really say is I have a y equals right here, a y equals right here, and a y equals right here. Yes, I'm going to be plugging in for x, but really isn't so bad. Okay, plug in for x, it gives us a y. All right, so first question, we're going to plug in 3, so 5 times 3 minus 2. And it is that simple. That's all there is to it. So 5 times the x value of 3 minus 2, that's going to give us 13. 15 minus 2 is 13. The next one is 5 times negative 2 minus 2, and that's going to give us negative 12. Again, you're replacing whatever is in place of the x. So again, come on, in this problem they put a 3 in place of the x. In this problem they put a negative 2 in place of it. So we're going to look down here. I'm going to erase those y's if I can. All right, so I'm going to put a 3 in place of the x, and I'm going to put a, come on today, what is going on? 3 in place of the x, and then a 0 in place of the x. I'll just do the 3, save us some time here. I think you guys get it. So 3 squared plus 4 is going to give us 13 again. Lucky number 13. 0 squared plus 4 is just 4. And the last problem, it's going to become 2 to the third and 2 to the negative 2. When you plug in the variables, you end up with 8 and 1/4. All right. So, when is a relation a function? When is it one-to-one? Like I was saying before, we use the vertical line test. So if any vertical line passes through a graph at more than one point, then the graph is not the graph of a function. All right. So if it crosses it once, it is a function. So we draw a little line here, put it in red. See how it crosses only once? Come on, today. Crosses only once. No matter where I draw it, you see it's only crossing once. So it is yes. And you can write passes vertical line test, right? VLT for vertical line test, or 1y for each x. And that's what that's supposed to say there, 1y for each x. Is it one-to-one? Well, something is one-to-one if it also, right, passes the horizontal line test, which means it can only cross once when you go horizontal. So I have all those on here. I should erase them for you. So we do the horizontal line test as well as the vertical line test. You can see that when I draw my horizontal line across, no matter where I go across, it crosses once, the vertical line. So it is a one-to-one relationship. So it is yes. Oops. Come on. Yes. And it's the vertical line test and the horizontal line test, or you can say it's 1y for each x and 1x for each y, which I have written right here. Okay, so you could also write this for the explanation. Okay, let's jump over here to the right. Is it a function? Well, when we draw this vertical line right here, it crosses more than once. So we can say no, it is not. All right. More than 1y for each x. Let's just draw a line right here. All right, you can see it crosses here and here. So each x has more than one y. Okay, and that's the same reason that it's not a one-to-one function, okay? It has to be passing the vertical line test and the horizontal line test, so you can give the exact same reason. So no, each x has more than one y. Same reason, no, it's not a function, all right? If you take a look at it, it doesn't pass the horizontal or the vertical. There's no way possible. All right, take a second. I'm going to pause the video. You should pause the video, I mean. Go ahead and try these next two questions, and then I'll post the answers. Okay, so here we go. First one, we have, is it a function? Yeah. Draw a vertical line, 1y for each x. Yes, there is exactly 1y for each x. But is it one-to-one? So it is going to pass the vertical line test, but does it pass the horizontal line test? And the answer there is unfortunately a big fat no. When you take a look at that y value of 5, so if you take a look at the y value of 5, you can see that it crosses right here and right here. So each y value, and not maybe every y value, but certainly all the positive y values, has more than one x value. It has 2. That's why it does not pass the horizontal line test. Take a look at the next question. Is it a function? Unfortunately, no. All right, as we draw that vertical line right here, we see that it crosses more than once. So each x has more than one y. That x value of 2 crosses at a y of, let's call it 1.5, and it crosses at a y of negative 1.5. That x value cannot have two y values. Let's move on. All right, so next style questions are just a different way of asking the same thing. The graph is probably the easiest way to solve, which is what I would recommend you do for these questions, is just plot the points and make a graph. So when you have a collection of points, you're still going to see if it passes the vertical line test. So you go over 4 up 1, over 5 up 1, and over 6 up 2. When you graph that, you can see that a vertical line is only going to cross once here, and once here. So it passes the vertical line test. Okay, so it is a function. Is it a one-to-one? No. So this is a function. Is it one-to-one? No, it's not one-to-one. And the reason it's not one-to-one, right here when you go across, it crosses twice. Go ahead and do the one right below it, this guy right here. I'm going to pause the video in a second, see if you can figure out what it does. So when you take a look at this one, you notice that you have 4-1 occurring twice. That's the same point, so it doesn't count against itself. So it still only crosses once here. You notice I put a red dot and a green dot there at 4-1. That's over 4 up 1. It still only crosses once, okay? Same with 5-1, it still only crosses once. So yes, it is a function because the vertical line only crosses once, but is it going to be a one-to-one function? The unfortunate answer is no. When you draw the horizontal line, it does not. So again, it's a function, but it's not one-to-one. Let's go ahead and plot the points for the next questions over here. Collection of points. You try these right here, and I'm going to plot them, and then we'll talk about it. All right, so we have to go over 4 up 1, 3, 2, and over 4 up 3. So as I draw my vertical line, yes, it's going to be a function because it only crosses once. As I draw my horizontal line, you can see that that also only crosses once, so it is going to be one-to-one. So we can say function with a check, and then it is one-to-one. The one below, all right, take a look, plotted the points. Does my horizontal line cross? So, and you can't really tell with my negative 2 up 6, negative 2 up 1, because my points kind of stink there, I'm sorry. But this negative 2 up 6, negative 2 up 1 should be over top of each other, I apologize. So this is not going to be a function, and if it's not a function, it cannot be one-to-one. So no and no. So not a function or one-to-one. Set mapping, the next couple of questions are really just a different way of looking at it. It really is just ordered pairs. You can totally take a look at it yourself and see how it is ordered pairs. So let's do that. Negative 1 maps over to 2. So if you need to, just write these out as ordered pairs. So we have negative 1, 2. The next one that we're going to have is 0, 2, 1, negative 3, 2, negative 2, and 8 to 3. So you go ahead and you can plot those points, but I think you're going to see some trouble when you plot the negative 1, 2, and the 0, 2, where you see them both go to the same value right here is kind of a dead giveaway that something's not working out so right. So in this case, the negative 1 up 2, come on, let's work here. Stupid thing. Negative 1 up 2 and 0 up 2 is not going to pass the horizontal line test. When you plot all the rest of the points, they do pass the vertical line test. I don't think you need me to show you that again. So it is a function because it passes the vertical line test, but it is not one-to-one. Take a second, do the same thing for the next one. Actually plot the points. I'm going to pause the video here in a second. I'll plot them, and then we'll talk about why it is what it is. So here's what we should have. 0, negative 2. Come on. 1, 0, 1, I'm sorry. 1, 2, and 3, 4. So you can see the vertical line test looks good here, but right here is not so good. So it's not a function, and if it's not a function, it is also not one-to-one. So not a function, and therefore not one-to-one. So the next couple questions that we're going to be working on, really just application questions, questions that show up on the Regents, kind of important questions here. So boiling water at 212 degrees Fahrenheit is left in a room that is 65 degrees Fahrenheit and begins to cool. Kind of what water does when it's really hot, right? That should make sense. The temperature readings are taken each hour, because it's fun to do that, and are given in the table below. In this scenario, the temperature T is a function of the number of hours. Seriously, if someone really did that, wow, that's boring. Anyways, so here we have it. All right, after 0 hours, that's why it's 212, and every single hour, somebody came back, we had no life, and did that. Anyways, evaluate T of 2 and T of 6. What you need to understand is this is function notation. T of 2 is saying what is the temperature at 2. And now that 2 is what you have to understand, what is it talking about. So it's T, it says, as a function of H. So what we should have here is T of H, which means this guy right here is an H, and this guy right here is an H. So they're saying when H is 2, what's T? So T of 2, when H is 2, that gives me 104. So the temperature is 104. T of 6 is saying at 6, what is the degrees Fahrenheit, which is going to be 68. The next question, the fun Regents question that totally messes with you, it says, for what value of H is T of H 76? So now they're saying, hey, we know that the temperature is going to be 76, kind of like it was 68, 104 here. The temperature is going to be 76. Now work backwards to figure out how many hours it was later. So we find out where the temperature is 76. We realize it happens after 4 hours. So we can say at H equals 4. And then the all-time favorite, between what two consecutive hours will T of H equal 100? Okay, so you're going to look at your graph, figure out where the table, the table, figure out where you see 100 showing up. And you look real quick and 100 does not show up, which doesn't mean you quit. You take a look again, you say, okay, between what two consecutive hours? Consecutive means one after another. So 4 and 5, 6 and 7, 8 and 9, so on and so forth are consecutive hours. So where is 100 going to lie? Well, 100 is going to be right in between here. I'm noticing that it's dropping, so it's someplace in between those two guys. So I'm going to put a little line right here. That's where 100 happens, which is between the hours of 2 and 3. Between 2 and, that's a horrible and sign. I quit. Come on. So between 2 and 3 hours. And we're good to go. Let's move on to the next question. So here we go. We have a function y equals f of x defined by the graph below. So what they're saying, even though it's not written, is this is the graph of f of x. So you notice that they plug in values in place of the parentheses. You have to know that when they put it inside the parentheses, that's replacing an x. So you just need to go in the graph where x is negative 1, 1, and 5. And what they're really saying is find y when x is this value, and this value. So when x is negative 1, I'm going to go over here, negative 1. You can see my dots right on it. So at f of negative 1, right, when x is negative 1, the y value is 0. So we're going to write that. Put a little dot right there. Yeah, horrible. F of negative 1 is 0. Now we've got to find f of 1. So we're going to go to where the x value is 1. So when the x value is 1, this is not in a nice spot this time. It's 1, right? So I got to go all the way up to here, and I got to count 1, 2, 3. It's 4 up. So f of 1 is 4. And the last one is f of 5. Take a second, try and find it yourself. So f of 5, count over. 1, 2, 3, 4, 5. It's all the way down here. Okay, so let's just double check. 1, 2, 3, 4, 5. And I got to go down 1, 2, 3, 4. So that's going to be down at negative 4 is my answer. Next question, what is f of 0? Well, that's not really a rocket science question. We just did a bunch like that. So f of 0, go to where it's 0. It's up here at 1, 2, 3. So f of 0 is 3. That wasn't so bad. What special feature in a graph does f of 0 always correspond to? Okay, so if it's a function, which when it's given this lovely notation, f parentheses, it is a function, which means it passes the vertical line test, go figure. F of 0 will always correspond to this guy right here on the y-axis. We call that the y-intercept. So 0, 3. So the y-intercept, that's horrible, but you get the idea. The y-intercept, which is 0, 3. Question C, what values of x solve the equation f of x equals 0? So f of x equals 0 occurs where the y value, this is the y value, right? Remember, f of x is just another way to say y, okay? So f of x, where's y equals 0? Well, y equals 0 here. Where else? Here and here. So what x values solve that equation? Well, it looks like x equals negative 1 was one of them. And then the next one is over 1, 2, 3. And the last one is 4, 5, 6, 7. So negative 1, 3, and 7 are the x values that solve that. So what special features are those? Well, they're not really a special feature. No one's really going to be all happy about finding those. But those are the solutions of f of x. They are the roots or the x-intercepts. There's a lot of different names for them. So you can say they are the solutions. Come on. Solutions, okay, of f of x. Or the roots. Or the Captain Obvious one, the x-intercepts. They have lots of names. Okay? Almost there. Between what two consecutive integers is the largest solution of f of x equals 3 lie? I don't know why I moved it up. Doesn't do us any good. So f of x equaling 3. Between what two consecutive integers does the largest solution? So we're going to start by graphing the line y equals 3. All right, it's going to make it probably the easiest way of doing it. So 1, 2, 3 is right here. So the largest solution, and we're talking about solution of x because we're looking for x values, obviously is going to be the farthest to the right. So looks like between here and here is where it's going to be crossing. So those are the consecutive integers that I just marked off. We just got to count all the way over, which is not fun to do on this iPad. So 1, 2, 3, 4, 5, 6, 7, and 8. So between x equals 7 and x equals 8. Between x equals 7 and x equals 8. That's a horrible 8. All right, last question. We made it. For a function y equals g of x, it is known that g of negative 2 equals 7. Which of the following points must lie on the graph of g of x? One of the cheesiest, easiest, most Captain Obvious questions that they could ask on a Regents exam that people get wrong because they're in a hurry. And typically on the Regents, they put one of the wrong answers that looks right first. Okay, so you need to know, very basic thing, that this is x. And if that's x, then there's only one thing left to be y. That's got to be y. So it should be the ordered pair negative 2, 7. People get confused once we start doing inverses. They don't usually get it wrong today. You're all thinking, well, how do people get that wrong? Once we start doing inverses, we start switching things. It gets a little bit more confusing, and then people end up getting this wrong. But keep in mind that inside parentheses is always x, and g of x is always equivalent to y. So the 7 is y. So answer choice 3. Okay, don't forget for your summary, things are changing a little bit. So when we're doing the summary, we're going to ask you a few questions that we'd like you to answer. How do we determine if a relation is a function, and so on and so forth. We'd like you to fill in the blanks or answer the question, just to make it a little bit easier for you to do the summary and for us to rate it after you get your practice done, of course. So get that practice done, fill out the summary. Life will be good. Thank you very much.